Let us learn about trigonometric functions. We know that trigonometry is a branch of mathematics that deals with the study of triangles, where we study the relationship between the sides and the angles of a triangle. Trigonometry is used in geography, astronomy, navigation, medical imaging, electronics, electrical engineering, civil engineering, mechanical engineering, architecture, oceanography and seismology, etc. And there is a wide range of careers that require the use of trigonometry. Let us learn about angles. We know that angle is a figure formed by two rays called the sides of an angle, sharing a common point called the vertex. This is called the initial side, this is the terminal side, and the common point is called the vertex. If the angle is measured starting from the initial side in the counterclockwise direction, the angle will be positive. Whereas if the angle is measured in clockwise direction, then angle will be a negative angle. And in this case, this is the initial side and this is the terminal side. And the common point is called the vertex. Therefore, based on the direction of rotation, the angle can be positive angle or a negative angle. There are several units for measuring angles. The more familiar unit of measurement is degrees. This is a 180-degree protractor which we use to measure the angle. It represents the angle between 0 degrees and 180 degrees. And this is a 360-degree protractor. So, a circle is divided into 360 equal parts. Every single part represents 1 degree. We know that x and y axis divide a plane into 4 equal parts. They are called quadrants. This is the first quadrant, second quadrant, third quadrant and fourth quadrant. If initial ray and the terminal ray coincide, it represents 0 degrees. And if the angle is between 0 degrees and 90 degrees, it is called the first quadrant angle. And 90 degrees is called a right angle. And if the angle is between 90 degrees and 180 degrees, it is called the second quadrant angle and it is an obtuse angle. And 180 degrees is called a straight angle. And if the angle is between 180 degrees and 270 degrees, it is called a third quadrant angle. And if the angle is between 270 degrees and 360 degrees, it is called a fourth quadrant angle. 360 degrees is one complete revolution. It is called a complete angle, where the initial and the terminal rays coincide. So, 0 degrees and 360 degrees take up the same position. In this figure, initial ray and the terminal ray are coinciding, which represents 0 degree. As we move the terminal side, the angle increases. This represents 30 degrees. This is 45 degrees, 60 degrees. These are the known angles for which we know the trigonometric values. And this is 90 degrees, which is a right angle. If the angle is between 0 degrees and 90 degrees, it is called the first quadrant angle and it will be an acute angle. And if the angle is between 90 degrees and 180 degrees, it is called the second quadrant angle or obtuse angle. And 180 degrees is called a straight angle. And if the angle is between 180 degrees and 270 degrees, it is called a third quadrant angle. And the angle between 270 degrees and 360 degrees is called the fourth quadrant angle. And 360 degrees complete one revolution. Therefore, it is called a complete angle. Again, in 360 degree case, the initial and the terminal rays coincide. Therefore, 0 degrees and 360 degrees take up the same position. Then second revolution. If we take one more complete revolution, 360 plus 360, it represents 720 degrees. Often we use angles which are more than 360 degrees. For example, a wheel covers 360 degrees in one revolution and 720 degrees in 2 revolutions, 1080 degrees in 3 revolutions, etc. See the third revolution, the angle will be 1080 degrees. Now let us measure the angle in clockwise direction. The angle will be negative. This represents negative 30 degrees, negative 45 degrees, negative 60 degrees and negative 90 degrees. So positive 270 degrees and negative 90 degrees take up the same position. And this is negative 180 degrees. So positive 180 degrees and negative 180 degrees take up the same position. This is negative 270 degrees. Positive 90 degrees and negative 270 degrees take up the same position. And this is negative 360 degrees. So 0 degrees, positive 360 degrees, negative 360 degrees take up the same positions. Now the second revolution. In 2 revolutions, the angle covered is negative 720 degrees if we measure the angle in clockwise direction. And for 3 revolutions in clockwise direction, the angle measured is negative 1080 degrees. Now we will write the different types of angles. 0 degrees is called a 0 angle. And if the angle is between 0 degrees and 90 degrees, it is called an acute angle, which is a first quadrant angle. And 90 degrees is called a right angle. And if the angle is between 90 degrees and 180 degrees, it is called an obtuse angle, which will be in the second quadrant. And we know that 180 degrees is called a straight angle. And if the angle is between 180 degrees and 360 degrees, it is called a reflex angle. And this will be in the third or in the fourth quadrants. And 360 degrees is called a complete angle. A complete angle represents 360 degrees because a circle is divided into 360 equal parts. Each part represents 1 degree. Now we will see what are reference angles. If we measure a first quadrant angle, that is between 0 degrees and 90 degrees, this is a positive angle and this is called a reference angle too. Reference angle is an angle between the terminal side of the angle and the x-axis. If the angle measured is an obtuse angle, that is the second quadrant angle, say, this is the angle measured, which is an obtuse angle. The reference angle is the angle between the terminal side and the x-axis, which is closer to it. This is the reference angle. If the angle is in the third quadrant, so it will be more than 180 degrees. This is the angle measured. So its reference angle will be the angle between the terminal side and the x-axis. The x-axis which is closer to the terminal side. And if the angle is a fourth quadrant angle, that is between 270 degrees and 360 degrees, say, this is the angle measured, which will be more than 270 degrees. And its reference angle is the angle between the terminal side and the x-axis, which is closer to it. This is the reference angle. Now let us learn the smaller units of degrees, which are minutes and seconds. Each degree is divided into 60 equal parts called minutes. And further, each minute is divided into 60 equal parts called seconds. These minutes and seconds have nothing to do with time. 1 degree is equal to 60 minutes. Minutes is represented by 1 dash and 1 minute is equal to 60 seconds and second is represented by double dashes. When measuring things like latitude, longitude or in astronomical measurements, we need the finer units of degrees, which are minutes and seconds. Now let us learn another unit for measurement of an angle, which is called radian measure. Let us consider a circle with radius r units. I am going to measure an arc length of r units along this circle. Let us join these 2 points. This is also r units. In this case, the angle subtended at the center will be 1 radian. The word radian is derived from the word radius, because that 1 radian is subtended by the arc length, which is equal to the radius. Let us see how many times will a radius wrap around the circumference of a circle. That blue line is equal to the radius of this circle. 1, second radius 2, third, fourth, fifth, 6r, and little part is left which represents 0.28 of a radius. So totally we have 6.28 radius along a circle. We know that circumference of a circle is 2 pi r. This part is 0.28 times the radius. Therefore, the total circumference of the circle is 6.28 times radius, which is 2 pi r, where pi value is approximately 3.14. So, 2 pi will be 6.28 approximately. Therefore, the circumference of the whole circle is the angle subtended by the circle at the center times the radius. Let us now consider this sector whose arc length is L and subtends an angle theta radians at the center. We know that the whole circumference of the circle is 2 pi times r, where 2 pi is the angle subtended by the whole arc length of the circle, which is the circumference of the circle. Therefore, for the sector, the arc length L will be the angle subtended by that arc at the center times the radius. Here theta is expressed in radians. But we have learnt the arc length of a sector formula as theta divided by 180 times pi r. In this formula, theta is expressed in degrees. Let us now see the relation between degree and radian. We know that a circle subtends 360 degrees at the center or 2 pi radians at the center. Therefore, 360 degrees is equal to 2 pi radians. Let us divide both sides by 2. 180 degrees will be pi radians. Again dividing by 2, 90 degrees is pi by 2 radians. Dividing by 2, we get 45 degrees is pi by 4 radians. Using this relation between degrees and radians, we can easily convert degrees into radians and radians into degrees. To convert degrees into radians, we multiply the given degrees by pi over 180. And to convert radians into degrees, we multiply the radians by 180 over pi. It is easy to remember these formulae. To get the answer in terms of radians, keep pi in the numerator. So, we multiply by pi over 180. To get the answer in terms of degrees, we keep 180 in the numerator. So, we multiply by 180 over pi. Now, we will see how to convert few angles which are given in degrees to radians. We know that to convert degrees into radians, we need to multiply by pi over 180. We usually represent radian measure in terms of pi. Now, 30 degrees. To convert 30 degrees into radians, multiply 30 degrees by pi over 180. So, the answer is pi by 6. So, 30 degrees is pi by 6 radians. Similarly, 45 degrees, to convert it into radians, multiply by pi over 180 4 times. So, 45 degrees is pi by 4 radians. Similarly, 60 degrees is pi by 3 radians, and 90 degrees will be pi by 2 radians. Now, let us convert few second quadrant angles. 120 degrees. To convert it into radian measure, we multiply by pi over 180. 120 degrees is 2 pi by 3 radians. Then 135 degrees multiply by pi over 180, 3 and 4. So, it is 3 pi by 4. Then 150 degrees, let us change it into radians. 150 degrees is 5 pi by 6 radians. 180 degrees is pi radians. Now, third quadrant angles, 210 degrees. So, it is 7 pi by 6 radians. Then 225 degrees, this is 5 times and 4 times, which will be 5 pi by 4. Then 240 degrees, changing it into radians, it is 4 pi upon 3. 270 degrees, 3 times and 2 times. 270 degrees is 3 pi by 2 radians. Then the fourth quadrant angles, 300 degrees. To convert it in terms of radians, we multiply by pi upon 180. 5 times, 3 times. 300 degrees is 5 pi upon 3. Then 315 degrees. This is 7 times and 4 times, which is 7 pi upon 4. Then 330 degrees times pi upon 180. This is 11 times and 6 times, which is 11 pi upon 6. 0 degrees is equal to 0 radians, and 360 degrees is 2 pi radians. So, these are the degree measures and radian measures of some common angles. Let us do exercise 3.1. The first question, find the radian measures corresponding to the following degree measures. The first subdivision, 25 degrees. To convert degrees into radians, we multiply by pi upon 180. We keep pi in the numerator to get the answer in terms of radians. Let us simplify this. We can cancel 5 times and 36 times. The answer is 5 pi upon 36. We usually give the radian measure in terms of pi. The second subdivision, minus 47 degrees 30 minutes, which can be written as minus 47.5 degrees. 47 times 2, 94, and plus 1, 95 upon 2 degrees. To convert degrees into radians, multiply by pi upon 180. We can cancel 5, 19 times, here 36 times. The answer is negative 19 pi over 2 times 36 is 72 radians. Third subdivision, 240 degrees. To convert it into radians, let us multiply by pi upon 180. We will cancel 6. The answer is 4 pi upon 3 radians. Fourth subdivision, 520 degrees. We will multiply by pi upon 180. We can cancel 2, 26 and 9. The answer is 26 pi upon 9 radians. The second question, find the degree measures corresponding to the following radian measures. Use pi as 22 over 7. The first subdivision, 11 over 16. To convert radians into degrees, we multiply by 180 upon pi. And pi value is given as 22 over 7. We will cancel 11. Let us cancel 2 here. 45 times 7 is 315 upon 8. 315 divided by 8 is 3 8s are 24, 75, 9 8s are 72 and 3. We can write this as 39 3 over 8 degrees. To convert 3 by 8 degrees, we will multiply by 60 because 1 degree is 60 minutes. We will cancel 4. 45 over 2 is 22 and a half minutes. So, this becomes 39 degrees, 22 and a half minutes. We can convert a half minute to seconds by multiplying by 60. It becomes 30 seconds. This is 39 degrees, 22 minutes and 30 seconds. The second subdivision, minus 4 radians. To convert it into degrees, we will multiply by 180 upon pi. Pi value is 22 over 7. 360 times 7. Negative 2520 upon 11. Let us divide by 11. 22, 32, 2 times 22, 109 times it goes. This can be written as negative 229 and 1 by 11 degrees. Now, to convert 1 by 11 degrees into minutes, we will multiply by 60. 60 upon 11 is 5 11s are 55 and 5 by 11. So, negative 229 degrees, 5 by 11 minutes. To convert 5 upon 11 minutes to seconds, we will multiply by 60. 300 upon 11, 2 11s are 22, 8 80, 77, 3 32 times. Approximately it is 27 seconds. The final answer is negative 229 degrees, 5 minutes and 27 seconds. Third subdivision, 5 pi over 3. This is easy because it has been given in terms of pi. Let us multiply by 180 over pi. Pi gets cancelled. The answer is 300 degrees. Fourth subdivision is also easy. 7 pi over 6 radians. To change it in terms of degrees, we multiply by 180 over pi. The answer is 210 degrees. Question 3. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Number of revolutions in 1 minute is 360. Therefore, number of revolutions in 60 seconds is 360. 1 minute is 60 seconds, from which we can calculate the number of revolutions in 1 second. It is 360 over 60, 6 revolutions. And in 1 revolution, the wheel covers 2 pi radians. The answer should be given in radians. And in 1 second, the wheel makes 6 revolutions. Therefore, in 6 revolutions, the angle covered will be 6 times 2 pi. It is 12 pi radians. Question 4. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeters by an arc length of 22 centimeters. Use pi as 22 over 7. We need the answer in terms of degree measure. So, arc length formula using degrees is L is equal to theta over 180 times pi r. Arc length is given as 22 centimeters. Theta we need to find in degrees. Value of pi is 22 over 7 and radius of the circle is given as 100 centimeters. Therefore, theta is 18 times 7 over 10. 18 times 7 is 126 over 10, which is 12.6 degrees. We can convert 0.6 degrees to minutes by multiplying by 60. We can write this answer as 12 degrees 36 minutes. Fifth question. In a circle of diameter 40 centimeters, the length of a chord is 20 centimeters. Find the length of the minor arc of the chord. Diameter is 40, therefore radius is 20 centimeters. And length of the chord is 20 centimeters. This is 20 centimeters. Radius is also 20. All three sides are 20 centimeters. It becomes an equilateral triangle. So, the angle at the center will be 60 degrees, or you may use radian measure, which is pi by 3 radians. We know that 60 degrees is pi by 3 radians. Find the length of the minor arc. We have to find the arc length AB. Arc length formula is theta over 180 times pi r, or we may use the formula L is equal to theta r. Here theta has to be written in degrees and here it has to be expressed in radians. Let us use this radian formula. Arc length will be radian is pi by 3 times the radius is 20. The answer is 20 pi over 3 centimeters, or we may substitute the value of pi. Pi value is 22 over 7, which is 440 over 21. The answer is 20.95 centimeters approximately. Sixth question. If in two circles, arcs of the same length subtend angles 60 degrees and 75 degrees at the center, find the ratio of their radii. They have the same arc lengths L. Here the angle subtended at the center is 60 degrees and in this figure it is 75 degrees. We will take the radius of the first circle as R1 and radius of the second circle as R2. Arc length of the first circle is equal to arc length of the second circle. The angles are given in degrees, so we will use the degree formula. Theta over 180 times pi R1 is equal to theta divided by 180 times pi R2. We will use theta 1 and theta 2. Pi gets cancelled, 180 can be cancelled. R1 divided by R2 is theta 2 divided by theta 1. Theta 2 is 75 degrees and theta 1 is 60 degrees. We can cancel 15. 5 15s are 75 and 4 15s are 60. The answer is 5 over 4. The ratio is 5:4. Question number 7. Find the angle in radian through which a pendulum swings if its length is 75 centimeters and the tip describes an arc of length 10 centimeters. We need the answer in terms of radian measure. So, we will use arc length formula using radians. The formula is L is theta times r. The arc length is 10 centimeters. Theta we need to find and the radius of the pendulum is 75 centimeters. Therefore, theta will be 10 over 75, which is 2 divided by 15 radians. Second subdivision, we will use the same formula. Arc length in this case is 15 centimeters and the radius is the same 75. Therefore, theta is 15 over 75. We can cancel 15. It is 1 upon 5 radians. The third one, arc length is 21 centimeters and the radius is 75. Therefore, theta is 21 over 75, which is 7 over 25. Cancelling 3. 7 over 25 radians.